Okay. Again, I'm Diana Sinton. I work with iGuide at University of Illinois, and also some of you I know through my role at the University Consortium for Geographic Information Science. And iGuide and UCGIS are very happy to be able to support this VCO today. We're going to hear from Adam Cox talking about work he's done with oldinsurancemaps.net. This is one of our weekly virtual consulting office sessions. They're designed to be informal opportunities to learn about research and activities and ask any questions that you might have of the presenters about these technical topics. And we have these pretty much scheduled almost on a weekly basis through the rest of the summer. So stay tuned. If you check out the website, we try to keep that updated. We've got some great topics coming up in the next few months. And that's i-guide.io is our iGuide website. So with that, I'd like to turn it over to Adam, and thanks very much, Adam. I'll let you introduce yourself.
Oh,
you're
okay.
muted.
Now I can introduce myself. All right. Yeah. Hello, everyone. I'm really happy to be here. And if you attend next week, I will actually be here again, co-presenting. I won't be talking the whole time next week, but with my colleagues at University of Illinois, and on a completely different topic. But today we're going to talk about a project that you maybe you're familiar with, maybe not, but I'm really excited to be able to share this. A little bit about myself. So I am originally from Wisconsin and I live in Louisiana. I work remotely. I have worked for the Healthy Regions and Policies Lab at the UIUC in the Geography Department for about 2 years now. And I started in GIS a long time ago, fairly long, it feels like. 2011, I was getting into archaeology and anthropology at the end of my bachelor's, and that's how I learned about GIS. And I really never looked back. I worked for the National Park Service, and then I did a lot of freelance GIS and geospatial data consulting, which has turned into a lot of web programming, as you'll see today. And this project is the culmination of my master's thesis that I did at LSU, and it's continued and expanded a lot since then, as you'll see. So I'm going to begin by introducing the whole site and kind of some concepts behind it, and then I'll get into more into the workflow and database structure, and then give a demo. And Alex said Alex Michaels from the iGuide team, he had mentioned this could be a more technical talk, and so I'm going to get a lot more into some of the technical details. So, like Diana mentioned, feel free to put questions in the Zoom chat at any point. And I actually today have it open so I can read it. Usually I forget to do that and I get lost in the windows. So I'll try to keep track of the chat, but we'll have time at the end, I'm sure, for questions and answers as well. So here's the home page. If you go to it right now, it'll look like this. And like I was talking with Diana before, there's some other sites out there that we all kind of, I guess, have the same words, just in different orders. So Old Maps Online is a completely different project. It's much older and larger. This is a newer one that I made in the last few years, oldinsurancemaps.net. So I tend to characterize this site as a crowdsourcing site for creating and georeferencing, or creating and viewing georeference mosaics of historical fire insurance maps from the Library of Congress. It's kind of it in a nutshell, and some fine print or sort of details here. It's free to use. You can sign up, and then any of the work that people create is considered CC0 or Creative Commons 0. So if you create control points for georeferencing, you are making them in the public, essentially, and anyone can use them. All of the Sanborn maps on the site are in the public domain, and the software itself is built from a lot of different open source components, which I'll talk about in much more depth later, but you can also view the code base. It's also published open source under the GNU GPL license version 3. So feel free to check it out as I go through the talk. A more technical version of describing the site is that it's a Django application that's integrated with Svelte and OpenLayers to facilitate a browser-based workflow for creating and storing georeferencing data, and applies that information to scan historical map images to create geospatial outputs, such as geotiffs and dynamic web services. So that's saying the same thing, just in a different way. To get some of the technical words out there ahead and maybe answer a question right away that people may have about some of the platform and the framework. Before going further, I wanted to highlight this kind of kernel in the middle of this is the idea of a workflow for creating and storing georeferencing data. And so what I mean by georeferencing data is not the creation of the actual layers or images in the end, but the data that's needed to create those, or even kind of annotation. So as you'll see, it's around the creation of these extents, like the boundaries of images, and then the control points that are needed to georeference images, and then a mask that you can use to trim the images. So all of that will become a little more clear, but I just wanted to kind of plant the seed early in the idea of collecting that level of data and not creating just a lot of TIFFs. So what are Sanborn maps? And this is a kind of the core piece of the content, or what is in the site are these Sanborn maps, and they were made for fire insurance purposes. This was a map company that started in the late 1860s, and then they made these fire insurance maps into the 1960s. They became a massive company and essentially were a monopoly on the fire insurance mapping industry, especially by like 1920. And their maps cover almost 10,000 or maybe over 10,000 different cities and towns across North America. Often they came back and mapped the city multiple times. And the maps contain everything you would want to know if you were an insurance company that was underwriting for fire damage, as you'll see here. So here's what they look like in person. I went over to the public library the other day to the special collections and took some pictures. As you can see, they are really big in person. This is just a handful of New Orleans volumes, but again, multiply this across the entire US and many different years, etc. You open them up, there's these beautiful title pages. And on the right, I'm showing this is a key map that is very commonly in the Sanborn maps. So this shows where every sheet is laid across the city. And then the actual kind of the meat of the volumes here, the actual content is extremely detailed, as I'm showing here. So as you can see, they have all kinds of annotations around what's going on in each, well, they have each building to start, and then they have a description of what's going on. Sometimes it just says D for domicile or dwelling, or S for store. Other times it has the name of the company, all this information. And then the colors, it's color coded by building materials. So red is brick and yellow is wood frame, and there's some other colors too you might encounter. So they're just really rich maps, and they are used all the time for a wide variety of historical applications, and modern sort of analysis of how neighborhoods have changed over time, of course. So the best place to find these, the largest online digital collection is housed at the Library of Congress. And that's the collection that I built this workflow around in the beginning. A lot of other universities, libraries, et cetera, have their own smaller collections and will probably have digital copies. UICUC has, if you look in the library websites, you can find scans of local Sanborn maps. The Library of Congress has a massive collection that was created through copyright deposits. So they have and what they've published what they've scanned is all in the public domain and accessible, and they have APIs for it. So it's a really solid kind of foundation for building something on top of. Okay, so now we'll get to this idea of georeferencing, and some of you may be familiar with this, but just a little bit of context around what it means and how I'm using the term. I think it's a kind of a general term that's used in a couple different ways, but I'm using it here to talk about the process where you take this image on the left, a scan of a historical map, and then integrate geospatial data into it to turn it into a spatial data set. And so this can now be used within any sort of spatial data context. What you see in this image are these X's, these black X's, which are ground control points. And those are linkages between a location on the left, a location on the original image, like in pixel space, so to speak, a linkage between that, and then on the right, a latitude, longitude coordinate. So once you make these linkages, algorithms can run underneath and kind of create this output. And now it's a geospatial data set. So that's kind of the other way to look at it. It's just turning these standard map files into geospatial data sets. And then you get to treat them as a normal raster in this case. A historical map is really just a raster once it's been georeferenced, which opens up the door to all sorts of different analyses, which I'm not even really getting into today. It's more about how we get to that step. So this project started where I was, with this thesis, I was wanting to not create the first online web georeferencing site, because there's a handful of them out there already, and some have been around for quite a while, like MapWarper. You'll find a lot of great content on MapWarper. It's a really solid site that's been used by a lot of different organizations. I wanted to try a little different approach, and for one, I based it on the Sanborn map collection, but for two, I wanted to kind of use some ideas from this concept of the archival commons, and was reading a lot more about crowdsourcing kind of philosophy or approaches. So I won't get into that today either, but that's kind of where this came from. And I did a pilot project early on. Oh, I guess a couple more slides here. So just recapping, the idea is and a big focus is on mosaics. So not just georeferencing an individual page, but to take a set of pages from one of these atlases, and then through the georeferencing process, turn it into this as a seamless mosaic of the content all spread out across the city in this case. So I did this pilot project at the end of my thesis, and since then, and that's why there's all the maps in Louisiana, as you can see in this little image, kind of shows where things are distributed across the US at this point. In fact, there's more now. I think this image I took a little while ago, the screenshot. So we did this pilot project, and then since then, it's really been expanded a lot by different people. And I'll highlight the very bottom point. Well, a lot of numbers from, there's a lot of different maps in there, a lot of georeference layers. But the bottom point I just want to highlight, so a lot of funding has come through an NIH grant through the University of Michigan. And they have specifically been using the site through a team at the University of Richmond's Digital Scholarship Lab, who has had students using oldinsurancemaps.net pretty much every day for the last 2 years, and kind of constantly georeferencing like 50 cities, the maps from around 1950 for a large research project they're doing. So it's been in use and kind of slowly growing since. Okay, so I'm going to move on now to talk a little more in detail about how the workflow has been designed to handle this map collection. And I guess I'll emphasize right now that this workflow is really flexible, and while it was designed around the Sanborn maps, it actually works. So far, I've found it works great for any types of maps, anything you want to georeference. Really, the tools are in place for it to be done. So I'll introduce this topic by talking about some of the challenges that I had to work around when designing this whole system. So Sanborn maps, it's not that we're just doing an individual page here or there, but we really need to treat these pages as part of an atlas or part of a multi-page volume. And that volume can have one page, is really common. There's just one map, a one sheet for a tiny town. But it also could have 100 pages. So you need to kind of make a workflow that handles that multiple pages just as well as it handles one. The next thing that I knew I had to figure out and kind of deal with is the fact that these maps very often have a lot of insets in them, or different parts of the page will contain different parts of a city, for example. So on the left is This is one page and it has three different maps in it. It has, one on the right, one this little on the bottom corner, and then the main, the main part of the page. So these all need to be georeferenced individually. So you need some sort of way of handling that. And it's not always the case. As you see in the middle, that's just one, the one sheet has one map. So that's very easy. But then it gets kind of crazy where it might be like 13 different little pieces within the same sheet. And one example I should add to this slide is where it's not like an inset, it's really that the page is just split in half and there's two maps on it. So how do we handle multiple maps on each sheet? The next layer of complication really, or a characteristic that it was important to accommodate, is that there's multiple map categories of maps or cartographic content, you could say, within a single atlas. So I call this unimaginatively the main content, which is kind of what I was showing those detailed pictures of. These are Sanborn maps, kind of the what you would think of as a Sanborn map. But I also earlier showed this key map. So like I mentioned, a key map is essentially an index or like a zoomed out smaller scale index map that shows where all of the sheets are located across the city. Some maps even zoom further out because there's multiple volumes across a large city. So this is a different kind of scale of map within the same atlas it may be. And then a final example of this is a category I didn't even know existed before I started this project, but these skeleton maps. And a skeleton map shows it's the same extent and scale as the main content, but it has no color and no annotation. So I didn't want to lose these things. I didn't want to erase them, but needed to handle them somehow within the system. Okay, the next thing is, and if you've ever done work like this, that once you georeference a bunch of these sheets, they overlap each other on the edges and it becomes a really big mess. So somehow you need to trim those margins so that you're not overlapping one piece with the other. And so how do we deal with that at scale in kind of an efficient way? And finally, an example I'll show is there's all this non-map content, like these really great title pages or a text index. I wanted to make a situation where those weren't ignored, but you could handle them and kind of work them into the whole thing. So to recap that, we have, all of these different characteristics that were challenging to work around at first, but I decided to think of them as strengths really, or features, not bugs, because it was really crucial that this was handled well. And like I mentioned, it kind of created a much more flexible system. So now I'm going to go do a live demo of the site and kind of walk through a little bit of that process that I designed to handle those different challenges. And I think you'll see how it all kind of fits together then. So from the home page, I'm summed in and I had added a Champaign map earlier to kind of show you. So this is the most important page really, and per atlas or per volume, it's like a summary page showing the progress over the course of all the different pages in this volume. And the way it works is by providing a step guide through the different stages. So they're in this unprepared section, then you would prepare, and then you georeference, and then there's a couple other categories here that I'll demonstrate. So I'll walk through just kind of give a demo of what it looks like to work through some of this. So I'm going to start with this first one. And so this preparation step is where you handle those different pieces. In this case, we can see there's multiple types, there's like multiple areas here that need to be handled separately. So I'm going to choose this split this document. This brings us to this splitting interface. And the way I built this is such that it works as if you were using scissors. So you're not drawing polygons, you're just drawing lines. And so the lines, and you can overlap at the end, it doesn't really matter. These get processed into regions and kind of cut it across. So it's really fast to do this, even if you have a bunch of insets. it makes this a pretty painless process to create these different demarcations, basically. And typically, I don't have really solid guidelines besides always those black lines need to be separated because those always denote different areas. But in this case, I'm also going to split off that text index here just for illustration later. So we've made those regions. It could split more of this off, but I won't right now. And then submit it. So now what's happening is kind of on the back end, there's a task that's running and it splits that into what we had created, those 4 different sections. And you'll see a history here that kind of gets developed over the course of work on this map. All right, so now we've moved 1 from the unprepared to the prepared section into these 4 pieces. And so right off the bat, I'll do this one thing here. We can set one of these as a non-map, which is this text index. So set as non-map, it just moves it down to here. That's really easy. But the more important thing is we'll start to georeference one of these. And I'll just do this first one to give an example of how that looks and how that works. So the interface for georeferencing is pretty standard in a way, in that if you've georeferenced anything before, there's some sort of version of this. And the way it works is to provide a place where on one hand, you select, you create points on this left side on the original document. So I kind of checked out these before. So we have Vine and Lynn. I like to recommend that people use intersections. So I just created one control point linking here with this intersection. If I go straight down to John and Lynn, go down to John Street and here, and I'll make one more, and you'll see, and so we'll go to John and 4th, you'll see that after 3 control points have been made, that's enough information for the system to generate a preview for you that shows where the overlaid map exists now that it's been georeferenced. And so this is kind of a lightweight preview. It's really useful because it's easy to get them wrong at first, and then you have to move it around. And then in this case, actually, you can see up here this Grove and what is that, 5th Street. It's gotten it's a little distorted, so I'll add one more control point here that will be enough to kind of cinch it up, so to speak. And so I'm only using 4 right now. You can put in more. There's a point at which adding more and more doesn't really improve anything. It just reinforces. So usually wouldn't say you need to add more than like 8, but 4 is a good minimum. And so what that's done, so I submitted that and now it's processing, and it should be about done now. Uh-oh. Yeah, okay. So it did update, and typically it has this little locked notation saying that one is locked, which is how you can have multiple people work on the same one at once. So now that that's been georeferenced, it's available here in this mosaic preview. And the final thing I'll show is classifying this and calling it a key map, which is the category that it is. By default, it's main content, but so I'm going to reclassify it as key map, and now it shows up in a different category. As you georeference more items, then they kind of show up further in this area. So that's all I'm going to show now in terms of demo and kind of live showing how everything works. But hopefully that kind of illustrated handling a lot of those past pieces. And so I'll kind of walk through that a little bit more just with some diagrams. So we started, well, in these diagrams use an example of a 3-page or a 3-document map. So we started with those 3 originals, and then through those preparation step, you split, in this example here, you split one into 3 pieces. The other 2 you don't have to split. So now you have what are called regions in the database. And those are, as you can see, like the different areas that need to be georeferenced. Next is this georeferencing step where you actually take those regions and add the control points as you saw, and then that turns into layers. So that's the process that turns those into layers. And then that final step that I showed where you classify and you set apart different sets of different categories of content, that results in what I call layer sets. And so these layer sets are a really important grouping. And I'll talk about that in a second here. But this whole processing overview, just to kind of put it all together. So you're kind of like splitting things apart and then pulling them back together into these mosaics. Looking at the names of the data model, basically, we have a map and then a document and then a region and a layer and then a layer set. So that's more or less this kind of a simplified version of the data model that makes all of that possible that you just saw. So to talk about layer sets just a little more, this is how we sort of normalize the idea of having multiple types of categories within an atlas. At first I just had, this, like, you could check a box and say, this is a T map. And then I learned about all the other types and I needed to kind of rework that. But these are also the appropriate level at which to trim those margins, which I was mentioning before. So we have all of these overlapping layers now. What we need is to trim them down. And so that's done with masks. And you kind of see here what it looks like when those get removed, the margins. So I had this, and I didn't demo it, but it's right at the bottom of that summary page. This idea of a multi-mask, which basically allows you to create a mask around each layer, but then also snap and kind of drag, and a very easy manipulation of multiple masks across all of the layers in a layer set. All right, so in summary, really, we had all those things that was complicated, and like I say here, normalizing each of those elements was kind of what it came down to. Is like, expect that there's going to be many different pages, expect that there will be multiple maps per sheet, and make it easy if there aren't. You kind of need to make sure the defaults are the sensible defaults, so to speak. So it's always really easy to just move straight through if it's the simplest version of a map, but that the tools for handling more complex things are right there at your disposal as well. And what I realized this kind of created, this is a piece from a paper that I kind of created from an article that I made from the original thesis. What it really came down to is not just like a mass georeferencing website, but it really is more of a comprehensive method for breaking down all these different pieces and then putting them into a place where you can handle them properly and kind of analyze or visualize them appropriately. Because there's a lot more you could do with everything that I just said, like all of those different outputs. You can do all kinds of text recognition, etc. And some people have. It's not really built into the site yet, but it's possible because of all those different steps. Okay, so now we'll get on to the final part of kind of what I had planned and talk a bit about some of the details of kind of what goes on behind the scenes. And I'm realizing I'm not sure folks' familiarity with some of these concepts. So if your eyes, glaze over, that's fine, especially because you can just go to the website and look at maps. There's a lot to look at. And but I want to start with just here are the components. Kind of mentioned this earlier, but so Django is a Python web framework, a web framework written in Python. And so that's what the main thing is built with. The database it uses is Postgres with PostGIS extension for spatial data operations. A really important underlying piece of all of this is GDAL. And I'll talk more about how I use that. I actually use it directly with Python bindings to do some operations, but it's also essentially a C library like dependency of PostGIS, GeoDjango, T-Tyler, etc. It's underneath a lot of things. And then there's background task running with Rabbit, MQ, and Celery, and Svelte and OpenLayers extension are the front end, like the JavaScript pieces that make the front end work. And then I'll talk a little bit also about how the raster tiling is done with T-Tyler. So it's not how it started. It didn't start quite with those same components. My original idea and implementation, sort of through that pilot project, was to um, start with this open source geospatial content management system called GeoNode and to extend it into what I needed. So GeoNode is a very nice project. It's a very robust system for essentially creating geodata portals. And it's also written with Django and Postgres. There's a lot of similarities. So I was familiar with those technologies and it was easy-ish to pick up and start working with. So what that implementation looked like was GeoNode, and I built this kind of ingestion method from the Library of Congress's collection to load those maps into GeoNode, and then an extension on GeoNode that created that georeferencing interface. So you're essentially within the existing GeoNode content management system, turning documents into layers through that georeferencing process. And one characteristic of GeoNode is that it is linked inextricably linked more or less with GeoServer, which you may have heard of, some of you may be familiar with, but GeoServer is a GIS data server that will create web endpoints and do a lot of different things, but creating web services for geospatial data. And it's a standalone piece of software that's linked with GeoNode. And so these two things really became a lot to maintain in the way I had set things up over the course of the pilot project. So after the pilot project, later that year and kind of continuing into the next year, I did a bit of an overhaul that essentially created my own Django app that would hold that database content I was showing, like the maps and documents and regions. And then instead of GeoServer for the GIS services and like the raster tiling, I implemented a new piece of software called T-Tiler. And this just is showing a little bit of how that simplified things on the server. It kind of just simplified the architecture and it was a little bit more modular, which allowed it to scale much, well, it wouldn't have been able to scale to the level that it has now if I had still kept with that older architecture. Actually, yeah, before going on, I'll just mention that so GeoNode and GeoServer, they just provide a much wider range of utilities that I didn't need. And so balancing that with the kind of overhead that they require, it became clear that this was really the way I had to go. So if you're not familiar with this concept of raster tiling, and I'm sure you have used web maps and you've probably noticed at certain points where it looks like it's loading pieces, like it's loading tiles. The way this works is that you have, in this case, a geotiff. I have this final output, so to speak, this layer, this geospatial data set. There's a layer on top of that, this tiling software that will request specific regions from that tile or specific regions from the layer called tiles, and then only show those layers or show those tiles when you move the map. So that if you zoom in, you're not loading the whole map into the web map interface. It's only loading these small pieces. And there's a lot of ways to optimize this and do it, which I won't really get into. But this software that I mentioned, T-Tiler, is a standalone, very simple and very nice to use raster tiler, which, as I say here, doesn't need to know anything about the database. It's just kind of sits there, and then I give it a URL to one of these geotiffs, and then it returns an endpoint that I use on the web map in the front end. So again, not sure if this is really useful to folks to know about, but it was just one of the elements that allowed the whole site to change a lot and really expand. Okay, so now we'll get a little more detailed into how the processes that you saw happen work on the server itself. So GDAL is this, like I mentioned, a geospatial data library, and it's kind of a bedrock. of a lot of different spatial data or spatial software. So I use it in a few different ways. And the first that I'll highlight is that live preview that I had showed in the georeferencing interface. GDAL has this great concept or sort of construction called virtual rasters, and so VRTs. And so VRT is a file type that's actually just an XML document. It's just text. It's a very simple document. And it allows you to kind of inject new annotation on top of existing files and then read that content into whatever software you're using if it's compatible with a VRT, which T-Tiler is. So as this diagram is kind of showing, I hope it's not too confusing, but when you create or alter control points in that interface, the server just, or the front end sends those control points back to the server, and then it injects them into a virtual raster, which is looking at the source JPEG in this case. And then you kind of have this linkage that ultimately ends up in a warped virtual raster that T-Tiler reads and turns into XYZ tile layers that gets shoved straight back to the front end. So that's kind of a process that works while you're doing that georeferencing. It automatically updates that preview, and it's a good way to kind of show what happens once you click submit, because really the same thing happens, but instead of T-Tiler generating the web map layer, there's just a GDAL command that says turn that warped virtual raster into a geotiff or a cloud optimized geotiff. So it's the same process, but then it outputs an actual file. And as you can imagine, it kind of accumulates those files. They slowly build up, because as you georeference one, then it creates that geotiff, and you move on to another, creates another. So I mentioned earlier that it's not just about creating single files, but it's about creating mosaics from those single files. So from a group of those files. So putting that together and kind of adding this extra dimension of multiple layers, we just chain more virtual rasters. And so this third level that you see here called mask, it takes that trimmed mask from the multi-mask feature and applies a trim cut line essentially around that warped virtual raster. And then there's a final step here that combines all of those into a single virtual raster, and then that gets turned into a geotiff. So again, apologies if this doesn't make any sense or is way too confusing, but it's satisfying just to kind of lay it out and kind of show what actually is happening. And again, the end result is this mosaic file that's important to have. So I'll just kind of speed through the last couple ones here, and then we should have some time for questions. I've talked a lot about the technical side. There's a lot of other elements to discuss too, of course. But when it comes to file compression and storage, I've been talking a lot about geotiffs. That's just kind of how I set things up in the beginning. The files come in from the Library of Congress collection as JPEG 2000 format, and then I convert them right away to JPEGs. Just it's more compatible with the later tools. I just showed that georeferencing and warping process, and then that in turn outputs a geotiff with JPEG compression, which is a lossy compression. It's kind of confusing here in that there's file formats and then compression algorithms, but a geotiff, you can have many different compression algorithms that you use in a geotiff, and in this case I use JPEG, which is loses a little bit of fidelity, but basically none. Nothing that's important. It just might slightly change a few pixel values. It doesn't really matter with these historic maps. And as you can see, it's a fairly small geotiff file, whereas before, I used this lossless deflate compression algorithm because I thought it was really important at first to make sure it was a lossless process. And the output file, as you can see, is 60 megabytes. So it's way bigger, and that doesn't scale well when you have tens of thousands of layers. And at this point, there's actually over like 130,000 files. And I recently moved all of this into S3 object store, like cloud storage, essentially, which kind of removes any sort of limitations on the server size. It doesn't matter anymore. But all those virtual rasters I mentioned, those are kind of tiny little disposable files. They still sit on the server. All right, so to wrap up a little bit, just to highlight and going back to how each portion of this process, or like every step of the way, um, it's creating files that can be accessed or downloaded or used in a few different ways. So what I'm going to do is head back to the site and just show you, if you happen to be on here and looking around in the future, where you can find how you can access the data that gets created. Because I haven't created a good page that is combines everything into. I don't have a great explainer of like where to find the files to download, but it's all there. I just haven't described this as well as I should so far. But we just created that, through that process, georeference this layer in the section here, and you may see it other places, is a downloads and web services piece. So right here, I can just download that geotiff. I can also get the text for an XYZ tile layer that could be directly used in QGIS, or I think ArcGIS Pro or online as well. You can use those as a dynamic web service. You can also open this file, and this is what a lot of people use it for, in a really cool project called Open Historical Map. So Open Historical Map is basically like an OpenStreetMap, but for history. And I'm not going to be showing the best example because it's the key map, but you could, if you had one of those main content maps, you would be able to just trace the historical buildings, and that directly puts them into Open Historical Map. So that's the thing that people have really liked to use. And then one final thing I wanted, really cool recent sort of reconfiguration of all that data, all of that georeferencing data, is to turn it into a georeferencing annotation as per the IIIF georeferencing annotation spec. So I'm going to show two ways to look at that. One is as JSON. So this is essentially pulled all of that annotation information from that one layer into one place. So we have fitting that IIIF spec. So we have, these are the collections of control points that kind of link pixel space to lat-long coordinates. And there's a selector here that would apply a trim if we had it trimmed. So you can get this raw annotation, which may not be super useful to you, but you can open it in this really cool project called All Maps. All Maps is built around a IIIF viewing, or is built around the IIIF protocol. So in this case, that annotation you were seeing is being applied to the image and then warped directly in the browser here. And what's really nice about this is that we can make the mosaics directly in the interface instead of having to create a geotiff of the mosaic. So I'll just show an example. If we're in one of these New Orleans volumes, at the top in this summary page is where you can find the mosaic downloads. And so instead of a single page like I was just showing, we can take, in All Maps, we can view all of that main content at once. And so that's what it will show up here in a second. And the most cool thing about this is that, for one, we're reusing all of the data that's been collected by the georeferencing process by different people. But for two, if we look at the annotation, and this should, yeah, it's loaded, but if we look at the annotation, oh, it's because well, the insurance maps is taking a while to generate. So it takes a while to generate that annotation. So we're viewing this all at once. This is a single annotation with a list of all the layers. And so this is what it looks like with all those individual items. But the final thing I want to show is that this is reading not from any of those geotiffs, not from any of those files that I mentioned, but it's actually reading directly from the IIIF server at the Library of Congress. So it kind of has taken all of that annotation that I was talking about earlier, those different types of annotation, and combining it into a new spec and displaying it in a new way. So I think I'll end there. And here's the some contact information. Feel free to get in touch. Definitely want to acknowledge, for one, the Healthy Region Policies Lab. We did a georeference-a-thon last year where I came up and we all worked on some Champaign and Urbana maps together, which was really fun. But some other organizations, the project owes a lot too. So big thank you to them. And of course, all the people who have georeferenced content themselves. Yeah, so thank you. And yeah, open for any questions and feel free to get in touch later too.
Excellent. Any final questions for Adam? Adam, that was super.
Hey, Adam, Diana. This is Molly Webb from Washington University in St. Louis. I have a question for you.
Yeah.
Hi, Molly.
Hi. First of all, thank you so much, Adam, for your presentation and for really digging into those technical details. I really appreciated that. We have a similar, smaller fire insurance map collection in our holdings that we have been, over the years, working on getting georeferenced, first with a web-based vended crowdsourced georeferencing product, kind of like the one you've described in this presentation, and then more recently with a desktop-based workflow. And so my question, Adam, is in your georeferencer, when users actually get into georeferencing the maps, do you include in that georeferencing area any historical boundaries or historical data to use in areas that maybe have been disrupted with new development? That's a big issue in the collection that we've been using because a lot of them are in downtown St. Louis, and downtown St. Louis is now bisected, trisected by many different interstates. And so a lot of the historical maps are in areas that are now basically interstate. And so that's kind of why we moved to the desktop-based process, so we could bring in historical reference files. And so I was just wondering if your georeferencer included any historical information to use as reference when georeferencing.
Yeah, that's a great question because people have asked for it in different contexts as well. So short answer is not in a very flexible way. And there's no way for you to say, oh, I want to add this reference layer right now. But I will show you a couple of things that I have added, and I hope to do more of this. I just kind of haven't. Okay, and this one didn't have it. I thought I might. So so one thing that has been super helpful, and I know I've added it for Cincinnati. So just let me yeah,
no problem.
Essentially what I've done is created a workflow where I can fairly quickly add parcel layer, like a current parcel boundary layer, which is almost what you're talking about. It's not quite, but with these Sanborn maps, it's extremely useful. So so I'll just kind of show how this looks. And there's some kind of reference, remove some of that for right now. But for the cities that I've added it, for the cities that I've added it, there's this little button for parcels. So what this does is it actually and you can see this, who georeferenced this, they did it. And instead of doing the street intersections, you can create control points on intersections or corners of parcels. And very often these do line up with what's on the Sanborn maps, even in some spots where um, where like things have been rezoned or streets have been removed. Sometimes the current parcel map still shows that. And so that was kind of my first stab at creating something really useful for along those lines. But there isn't yet a way that's like, here's an image server from, state of Missouri or something. And they have, if you have, say, historical aerial imagery service, I don't have a good system yet for just adding that straight in here. But I want to. It's something I do want to add. But it certainly it makes a lot of sense to do this on a desktop where if you're adding in all sorts of, wide variety of different things. One thing I didn't show is that there is a satellite imagery, sometimes more useful, sometimes not. But there's a lot more that could be done to improve this georeferencing interface, and that's one of them. Is kind of a better system for arbitrary reference layers. Yeah. One other thing I'll mention is that once you've georeferenced other content from the map, you can kind of cheat around a little bit and show it in here and then connect. For example, I could connect this one, I could georeference from here to here, right? So you can kind of like stitch together pieces, which is really helpful when you get to a spot where there's a stadium now, but there's still all the the sheets around the stadium are easy to do correctly, but you can't really use control points on top of the stadium. Sometimes having these, like, being able to see the stuff next to it at the same time as you're georeferencing allows you to fill in those gaps and kind of move across those wider areas.
Great. Thanks so much, Adam.
Yeah, no problem. So someone put a message in the chat, and he says, when it came to starting a new GIS career, did it stem from your master's thesis, or were you able to find another way, pull the certificate? So question about kind of starting GIS career. I will just say I got into GIS a long time ago, right when, and specifically through archaeology, and I was making maps for reports, and then I got a job for the National Park Service. That was kind of a database creation job. And that was really, again, that was quite a while ago, but it was the first time I had like an industry job in GIS and was doing digitizing kind of all day and kind of designing things. So I really don't know much about the job market since, because one thing I think you can probably tell from this project, moved a lot away from GIS per se and a lot more programming and kind of web development, mostly following passions that I had kind of developed over time. And I can't really recommend this to people because I don't think it's a great precedent, but I did a lot of volunteer and very random GIS projects before I had got a job a long time ago, like talking with the local county GIS guy, and he kind of pointed me to a conservation organization that needed some maps. There's no silver bullet, but definitely a lot of networking, and I spent a lot of time unpaid. I don't recommend it, but it's just like that's kind of how some of these things have slowly evolved for me personally. Yeah. I don't think it's a great answer, but that's my personal answer. Yeah. Someone asked about the recording. I'm going to say yes. I assume the recording will be uploaded. And you wanted to delve into some of the topics, absolutely email me if you like. I'd love to talk about any of this more. I also will point out, I kind of just started this. I made a blog where I've been putting past presentations, like videos to conference presentations before, and hope to write more little tech pieces about some of this. And I'm going to backfill here as well, because like I said, I just implemented this blog, but I have a lot of things to kind of put into it. So check out the blog too. At some point, I hopefully will have some more topics and content in there. But yeah, absolutely feel free to get in touch.